Hello everyone, let's imagine you have an object. You've already made textures for this object and even created a material. And now you want to duplicate this object for some reason. Maybe you want to fill out your scene or something. But as soon as you duplicate this object, you quickly realize that it's all the same. All the same colors, all the same textures, which is normal. So maybe I'll just select one object, duplicate the material, and with the help of a U node, shift the color a bit here and there. And there, I have a variation. And now I just need to repeat this however many times or however many variations I want. But as some of you may know, this is exactly how you get a material tab that is full of repeated materials, just for these slight variations, which is a pain to navigate. But what if we could just create a material that automatically creates some variation? Just like this. Enough preamble. Let's figure out how to do it. Now, let's use a cube to show the basics. I even put bevels on my cube because I love my tiny cubes, and you should too. I'm using the default material in Blender for this cube. It's just a PBR shader connected to the material output. I haven't changed any of the variables. We'll just be focusing on the color input. You can actually use this technique with some changes and apply it to every other input on the shader. But for this video, we'll just focus on the color, keeping it simple. Now, let's start with the object info node and connect the random output to the base color input on our shader. You won't see anything happen right away, but as soon as you duplicate your object, you'll see that every new object is a different shade of gray. This is happening because the random output basically gives each and every new object a random value from 0 to 1. And when you connect this value to a color output or a color input, in this case, it translates it to a scale from black to white. Black being 0, white being 1. Now, we'll use a color ramp node to have better control of this whole situation. And I need you to understand this. Right now, the random value basically corresponds to the position value on the color ramp node. Which means that, for example, right now, the black slider that we have selected is in the position 0. And then we'll have a gradient of all the other colors until we get to the position 1 that has the slider white. So we have a gradient from black to white. And if we move the black slider to the position 0.5, this means that half of the possible values will be completely black. And that's why we have half of our cubes black. Now, instead of black and white, we can directly translate our values to colors. So I'll just throw here some colors. Now we have a gradient from blue to green, not black. And all our cubes are a different shade of this gradient. It's pretty neat. You can also change the color ramp node from linear to constant, and then you'll only have either one or the other color. You can actually just add more colors if you want, but this way you won't have any gradients. It will be just the colors you have on your sliders. This is just giving color directly through the color ramp node to our material. But most of the time, we'll want to use this to change an existing color or texture. In this test, we'll use an RGB node to mimic a texture. And I'll also create a new color ramp because I'll need a fresh one. And I don't delete this one because of my crippling fear of losing things. But we don't actually need it anymore. So to actually change the color or texture, we'll use a U saturation value node. So pick one of those up, and I'll just call it U node from now on. And to make things simpler, I'll change my color ramp to be full black. We'll later connect this color ramp to the U value on our U node. But for now, I'm just gonna manually change our U to be 0, because I want to show you that if you connect the color, a U value of 0 changes our cubes to be yellow. If we connect now our color ramp to the U value, since our color ramp is full black, we'll also get yellow cubes. This is because, as I said previously, black equals a value of 0, and we're connecting a color output to a value input, so it translates automatically. Now, if we set our color ramp to be the default with a gradient, we'll see that we'll get color variation magically. And you might think, isn't this the exact same as if we connected the random output from the object info directly to the U? Yes, it is. But that's because our color ramp is in the default values. The real power of our color ramp is that it can contain our random values. We can give it a minimum and a maximum. Remember that our U set to 0.5 is the default value. And let's say we don't want to shift the color all the way to 1 or to 0. We want a contained shift. You can go to your color ramp and in the position 0, that's the random value 0, we'll just set the value of the color to be 0.4. And if we go to the position 1 and change it to be, let's say 0.7, now we have a minimum and a maximum value that go from 0.4 to 0.7. And you can see that our cubes are now from pinks to blues. We don't get every single color as we did previously. But now let me talk to you about trees. This is a more real example, that something that can happen to you, because most of us have used trees, and you know it's one of those objects that you tend to duplicate a lot to fill out your scene. You're not gonna make a million trees, right? I have here our holy grail of 3 nodes that give us our color variation. I've already connected the color of our tree directly to the U node, and now if we connect the U node to our shader, we'll get a different color tree. And if we duplicate this tree, we'll always get a new color, so on and so forth, until we get a rainbow color, just as the cubes. And this is a perfect example why we want a color ramp to contain our values. I don't want a rainbow forest. I just want a small variation of greens in my forest. So I'll change out my values on the color ramp to be the minimum of 0.4 and the maximum of, let's say, 0.6. This way, as you can see, the color variation on the trees is really contained to the greenish tones. Let me show you another example, this time using grass, another very common object. Right here by the side, I only have one blade of grass. That instead of duplicating endlessly like I did with the trees, I used geometry nodes to distribute this one blade of grass throughout a plane. The distribution is very simple, so no need to worry about it. Right now, every single blade of grass is the same color, and it already looks good, but we can use the same thing we used in the trees to create color variation. So let's just connect the U node to the base color input on the shader, and you'll see that now we have color variation on the grass. I'll also change the leftmost slider to be black, just so you can see clearly the difference. And this is very cool because this means that this color variation also applies to instances of objects created in geometry nodes, which simply elevates the practicality of this particular technique to create color variation. It's a godsend, really. Now, all that's left is to show you how this can be used when you have real images as textures. In this case, I've already painted the textures I want for this stall, and I don't really want to paint new ones to create variation. So, using the same set of 3 nodes, I'm just going to connect my texture directly to the U node, and this will give me color variation. There, as you can see, now we have color variation in the doll. Every time we duplicate it, we'll get new color. But when using textures like this, you'll probably want to limit the variation to certain areas of the texture. And to do this really easy, you just need to create a mask to mask out the zones you don't want to change. In my case, I don't want the face or the foot of the doll to change colors. So I created a mask that has the clothes in white and the area of the face and the foot is black. When connecting this mask directly to the factor of the U node, it tells the node just to change the white areas and leave the black areas alone. And as you can see, the face and the foot of the dolls are the original color now. And there you have it, a material that creates random variation in your new objects. To finish this out, you're probably thinking right now, and what about not being random? What if I want to duplicate one of these dolls but give them a specific color? You could just duplicate it endlessly until you get what you want, or you can just shift the input instead of being random to be color, object, color. As soon as you do that, every doll is now the same color, and that's because they have the default object color still. You can just select one of those dolls and go to the object properties and change the viewport display color. That's the color you're using in the object info node. And you just need to change the value, not anything else, just the value. And when doing this, you're basically changing the U shift you want for that doll in particular. And you just slide the value up and down until you find the color you want, the color shift you want. And you can do this for however many dolls you want and manually select the shift you want for each one of them. And this is it, guys. This is how you can make color variation in any material using just 3 nodes. And you can do it randomly, or you can have control of it using the object color. I hope this helps, and I hope you liked this video, and see you soon. Stay safe.